Hi, this is the arm that I've been working on for my graduation project. It has 3 degrees of freedom. Each one is represented by a stepper motor mounted on a mechanical joint. You have the first stepper motor under the base. You can see it in this picture. And the second one is behind this link mounted on this joint, and the third one for the last link over here. I decided to start by writing the computer software to control this arm. Then I figured, why not to make a 3D simulator for this particular arm. I wanted the user to draw the full path, the full motion path on the computer first, then specifying all of the commands that you want the robot to perform, along with moving with this path, like closing the grip, opening the grip, accelerating one of the links, stopping abruptly over here, or anything like that. I just wanted to make a user interface that looks like the ones that you could find in 3D packaging programs. For example, like the user interface of the program like 3D Studio Max, or Maya, or TrueSpace, any 3D packaging like that. And the problem was, I didn't have any experience of programming the graphics, and it took me over a month in order to learn how to program the graphics, and I had to read a lot of a lot of books about game programming and stuff like that. Then I decided to use DirectX 8 under the development tool Microsoft Visual Basic 6. I've been using this language since I started programming from first place, and here it is. This is the result of my work for over a month and running the program. Here is my simulator for the arm. These controls over here, those slide bars will control each link individually, each joint, sorry, individually. If you move this slide bars, you can rotate the base of the robot. If you use this one, then you can rotate the first link, and the last one for the third link, as you can see. Also, I took the advantage and I made a function that can calculate the inverse kinematics of a specified position in the 3D space, and the position is represented by this small fire pole under the base of the robot. If I can look closer using the camera controls here, if I can try to position the camera to see this pole, and this control will move the pole along with the x-axis. As you can see, is the pole moving, and this one to move the pole upward. And the y-axis, this is the y-axis, the vertical axis is the y-axis, and the depth axis is the z-axis. If you can move the pole, as you can see it moving, then you press the get IK results, which is this button will call the function to try to calculate the IK results for this particular position of the pole. I'll try to press this button, then here is your 4 results for our 4 solutions for the IK or the inverse kinematic problem, trying to find the position of this pole. The first solution have a 148 degree of the theta for the base, and 36 degrees for the first link. The angle for the first link is 36 degrees, and 27 degree for the last one. If you double clicked on the first solution, and then you will see the arm moving to catch the position of the pole. Here, as you can see it. If I can move the camera in a way that you will see it in I'm sorry, it's just harder to control the camera using X, Y, Z buttons. I have to develop a more powerful tool to control the camera, just like what you find in the 3D packaging. You press the middle wheel of the mouse, and you will try to rotate the camera along with the origin of your world 3D coordinate system. But anyway, I just this will do the job right now, and try to adjust on the z-axis and x. There is a proper angle of seeing what happened for the robot in order to catch the ball. If I try to move the pole upward, and you can see another position for the robot to catch the ball, and then you get the new results for this particular position. Double click, you will get the first solution. We'll try the second one. There's a double click for the second one, and this the difference between those two solutions. The first one is what is called the elbow up solution. You see the elbow of the robot is positioned upward, and the second one is an elbow down. The third one will make the base to rotate 180 degrees to see the back of the robot to be on the face of the camera. And if I just try to focus on this small joint while I'm pressing on solution number 3, as you can see it, this is, I know it's not obvious from this drawing. I have to put something on this face of the robot in order to see the base rotating. Anyway, you have only 4 solutions for this 3 degree of freedom robot. If you increase the number of freedom by 1 or 2, you could get like 8 solutions, and if you increase that to 6, you could get like 16 different solutions for your arm. But for this one, you have only 4 to choose between them, which is the optimal solution based on your current position of each joint and other stuff. But I have to program these things later while I'm working on the real arm. Anyways, there is last thing. If you move the pole in positions that the robot cannot reach, then you will get this message, which is let's move down here and press IK result. There is no possible solution for this point. The robot cannot reach each point in space. And this was the last thing, and thank you for watching. Really, I want to hear from you. Any feedbacks would be appreciated. Thank you anyway, and wish me good luck, and see you.